Today we're just going to be solving index of refraction problems, and we're going to discover new formulas as well. What is the speed of light in water when the index of refraction of water is 1.33? So basically we all know this equation, and we're going to solve for the speed of light in the water. So this is the speed of light in the vacuum, and this index of refraction in the water is 1.33. So dividing this thing, so the speed of light in water is around 225,563,000, and we still got 909.8 meters per second. So this is the speed of light in water. So it's pretty much lower, right? Because the index of refraction is greater. Now let's try another problem. The speed of light in diamond is 1.24 times 10 raised to the 8 meters per second. What is the index of refraction of diamond? So this is quickly plugged in. So the speed of light in the vacuum is 3 times 10 raised to the 8 meters per second. And we all know the speed of light in diamond is 1.24 times 10 raised to the 8 meters per second. So we can do this thing, and as we can see, the meters per second will cancel. So the index of refraction is unitless. So we're going to divide this, and what we got is 2.41934. So this is the index of refraction in diamond. So it is the highest. The wavelength of light in vacuum is 600 nanometers. What is the wavelength of light in glass? The index of refraction in glass is 1.5. So we can just basically use this equation, wavelength of light in any material. So the wavelength, that's lambda naught. So we're going to use vacuum of light in a vacuum, that's 600 times 10 raised to the negative 9, and divide it by the index of refraction in glass. So the wavelength of light in glass is going to be 4 times 10 raised to the negative c meters. So it is much higher. Now let's try this. The wavelength of light in glass, n equals to 1.5, is 450 nanometers. What is the wavelength of this light in diamond? So the index of refraction is inversely proportional to the wavelength. Thus, we can use this equation. So we can just name things here. Our lambda sub 2 is equal to 450 nanometers. Index of refraction sub 2 is equal to 1.5. And n sub 1 is going to be 8.42. And we're going to find the wavelength of light in diamond. So we can just write everything into our equation. Our lambda 2 is going to be 450 times 10 raised to the negative 9, and divide. What we're going to find is the lambda 1 is equals to the index of refraction of the diamond, and then divided by the index of refraction of the glass. Now we can manipulate this equation and solve for the wavelength of the diamond. So we got this now. It's going to be 15 divided by 2.42. So using our calculator, the wavelength of light in diamond is going to be 2.78. Oh, this is a lot of numbers, so we just round it off. Negative 6 meters. So this is it for this video. I hope you learned something, and goodbye.